Hi everyone. Today we're going to be talking about sighting. And sighting is what artists do with their pencil to measure objects that they have in front of them and to create ratios between the height and width of that object in comparison to everything else in the still life. Uh, to do to do sighting, we need to extend our arm fully all the way out without a kink in the elbow. It's important to do that because as we bring our pencil closer or push it further away, the measurement that we're trying to capture is going to change. But if we extend our arm out all the way every time, then that measurement is going to stay consistent because our arm length is consistent and isn't going to change within the time that we're making the drawing. In order to create a ratio in sighting, we're going to use the tip of our pencil and we're going to put it at the top of an object or a shape. And we're going to take our thumb and place it on the bottom of that shape. So for example, this is the height of the green ball. And now that I have the height of the green ball, I can compare it to its width. And as you can see, the height and width are the same. This is a sphere, and when it's seen two-dimensionally, it would look like a circle. And circles have the same radius and therefore have the same height and width. Now, the nice thing is that once we have a measurement, and we always want to use, once we start sighting, we're going to use the same measurement over and over again. So for, let's say we're using the height of the green ball, we'll compare the other objects, in this case, this cube and this little silver container, and we will compare the height of the ball into these other objects. So if we compare the height of the green ball to the width of the cube, we want to turn our pencil horizontally, still holding that measurement, and say, what do we see in terms of the measurement as we compare the edge of the cube to the height of the green ball, and a little bit over the corner is 1. And then if we look at the rest of that measurement, it's about 1.5. So the height of the green ball goes into the cube with about 1.5 times. And we can do the same thing with the silver container too. What is the height of the green ball compared to, oops, sorry about that, the height of the green ball compared to, I'm going to try to stay on one line so that it's easy for us to see. Here we go. Compared to the height of the green container. So that is 1. And for everything that I see in that container, it's probably about 1/3. So if we were to take that measurement of the height of the green ball and compare it to how many times does that go into the pencil measurement that I have, it's probably about 1/3. And then what about the height of the green ball compared to the width of this container? And you can see that the silver container, I think I called it a green container, the silver container is just a little bit less wide than the ball is tall. So how do we translate that onto our paper? Well, the thing you never want to do is you never want to take a measurement and then place it onto your paper. That doesn't make any sense. Instead, you're creating a ratio between the objects and what you're going to do on your paper. So please don't take the measurement, just plop it down on your paper. Usually that just makes really tiny little drawings of the object that you're trying to draw. Instead, you have to make a decision first on how big you're going to want your composition onto your drawing. So for example, I want the width, everything, to fit here in my drawing. And I am making that determination first without measuring anything. And please apologize that because I want to be able to show you how I'm sighting with my pencil, the drawing itself might look a little askew because of the positioning of my camera. And so, of course, like might not be completely straight in the camera view. So I apologize about that, but I think it's really important for you guys to see the sighting. So now I've decided how wide I want the composition to be on my paper. And my question to myself then is, well, how wide is this composition? I'm going to use the height of the ball to make that comparison. So with arm fully stretched out, and I want to choose the height of the ball. And then I'm going to say, how many times does that measurement go into the width of everything that I see? So I see 1, 2.5 is about the distance of the width of the composition compared to the height of the ball. So what does that mean for our line here? So 2.5 is what I had decided. So somehow we need to break apart this measurement into 2.5. So what is the easiest way for us to do that? Well, it's probably going to be to do something a little tricky, or at least this is going to be the easiest way for me. So it's going to be 2.5. So what if I make my measurement just a little bit smaller, and then I take this part of the measurement and break it in half? And I can check my work, see if that's actually half. So put the pencil at the top here, take that measurement, compare it to this measurement, it's about right. And then I'm going to take this measurement, right now it's almost 1/3, and I'm going to think, where is the halfway mark for that? Something here. And so this is going to end up being 1 1/3. Sorry, 2.5. 2.5 is what I was looking for. I keep misspeaking. I'm sorry about that. So this is going to be the width of my composition. So now my question is, what is the height of my composition? I might have to do this a little bit backwards so I can keep the same measurement for my hand. So if I take the height of the ball and compare it to the height of everything that I see, and I have to think about what is the lowest thing in my composition. And I see that the bottom of the silver container is just a little bit lower than the corner of my box or the cube. So if I take that measurement again, the height of the ball, and compare it to the bottom of the composition, which is going to be the silver container, so that's 1, 2, and probably 1/3. So 2 1/3. Now, I've already established that one of these is my measurement of 1. So I want my composition to be 2 1/3 high. So thinking about how I want that to be placed on my paper, I think I'm going to say, taking this measurement, 1, 2, and I'm going to go below this line into 1/3. So thinking about what is 1/3 compared to this, so this would probably be 1/3. This would be 1/3. This would be 2/3. So I want 1/3, and I would bring that down. So my entire composition is going to fit inside of this rectangle, if that makes sense. I'm going to bring this a little bit closer because I think then it'll be a little bit easier to see. So again, my composition was 1 2.5 wide and 1 2 1/3 high. So now I have to make some other comparisons to figure out where the objects fit. So I know that the corner is going to be the edge of this silver container. So if I take the height of the ball and I compare it to the width of the silver container, I see that that measurement is just under 1. So if I take my measurement of 1 and I put it here at the edge of where that middle container is going to be, and I take into consideration how much less than 1 I saw before, I can think that the middle container is going to be about this wide. I also remember that the bottom of my composition, the lowest part of my composition, was that little silver container. So I can also take its height. So let's take the height of the ball and then compare it to the height of the container. Again, I'm flipping my pencil around because I can't sight because my arm's hitting the table. And if the only way to do it is to bring my measurement closer to me, and that I can't do it. So I'm going to actually go in the other direction. It doesn't really matter which direction we go in. So that is 1 and about a third. Let's see again. 1. Yep, and about a third. So if this is my measurement of 1, from the bottom here, I'm going to say 1 and breaking my pencil into thirds, probably right about here. So this is going to be the height of that silver container. So the other thing that I can do with that silver container is I can think about not only that it's going to fit within this space, but also I can think about its opening. So I can think, how high is that opening in comparison to the height of the ball? So if I take the height of the ball and compare it to the height of the opening, I think that it's also about a third. That feels about right. It seems like it's about a third of the, or just a little bit less than a third compared to that measurement. And so if I were to take the measurement of 1 and say, okay, where would that be? It's probably right about here. And that's going to be the opening of that little silver container. So before we go any further with the silver container, let's figure out where the rest of our objects are in comparison to this cube or this square that is going to be holding the rest of our composition. So I want to know, what is the space between these two objects? So I need to take that into account to know where the cube starts. So if I take the height of the ball and compare it to the distance between, I think it's about a fourth. And the other thing that I notice is that that measurement of 1, let's just grab it one more time, that measurement of 1 is almost the same as where the edge of the cube is. So if I take this measurement of 1 and then I compare it to my composition, I can say that about a fourth of the way on my pencil is where that cube's going to start. And then about distance from the edge, one distance from the edge is about where I see the edge of the cube, this part of the cube starting. And now let's check our work to see if I have this part of the measurement correct. So I can take the measurement of the ball and compare it to from the corner to the edge, and it's just a little bit less than 1. And if I take that measurement of 1, put it on where I have the corner of the cube, and that is just a little bit less than 1. So I'm actually quite happy with this measurement compared to the corner of the cube compared to the right-hand side of the cube. So now I have to ask myself, where does the bottom of the cube start in comparison to the silver container? And I can do that by holding out a horizontal line right at the bottom. So the cube starts higher than the silver container, and it's just a little bit higher. So if I were to think, again, that this is the middle of that silver container, I would say it hits about here. So if I extend this line over, I feel like the cube is going to start about there. So I know that it kind of looks like a messy grid at the moment. It will start to be more clear pretty quickly. So let's get one more measurement before we start playing with angles. So I know that this is the bottom of the cube, so that's here. So my question now is, what is the height of the corner of this cube? So if I take the height of the ball and compare it to the height of the cube, I think it's about 1. Let me just check that again. Yeah, it looks like it's about 1. So this is my measurement of 1. This is the corner of the cube. And this is going to be how tall the cube is. And I can check my work again. If I take the corner of the cube and put a horizontal line, I can see where does it hit the silver container, and it hits right at the opening. And I can compare on my paper, and that's about right too, where the corner of the container is hitting at right about the opening that I had said that this container would be. So these are almost in line with each other. So now I have the width of the cube, the corner of the cube, the height of the edge of the cube. And what I want to know is, at what angle do I see this cube sloping away from me on both sides? Because these are both at an angle, it is not parallel to me. The easiest way to find that out is putting your pencil horizontally on the bottom of that cube. You can start to see basically a triangle between the pencil and the cube itself. And by thinking about at what degree is that angle sloping away from you, and sometimes degrees are difficult to think about. So I would think about clocks, hands on a clock. So if the side of the cube is at noon, this is probably at about 2. So if I look at the side of the cube here compared to the edge of the cube, I want to make an angle that's pointing at about 2 o'clock here, so that this starts to be this part of the cube. And now let's do it in the other direction. What I see is that this angle here is sloping just a little bit less than this angle. And so if I'm thinking again about a clock, it's pointing towards a little bit less than 10 o'clock. If my pencil is at 9, I think that this would be pointing almost to 10, but not quite to 10. And so maybe I think it's something around here. And again, thinking about this edge and this angle. So now the interesting thing is that once we have this angle, then I can actually get the angle that's up here as well, the one that's sitting underneath the ball. Because this angle and this angle are basically going to be parallel to each other. And I can check that as well. I can hold my pencil horizontally here and observe that angle as well. So if I hold my pencil here, I can think about what angle is that. But I think it's basically parallel to this one. And then same thing here, this angle and this angle are going to be parallel to each other. The other thing that's interesting is that I can not only get this angle and this angle because they're parallel to each other, I can also get the one in the back. So this angle, and this angle back here are going to be parallel to each other. And then this angle, and the one back here are also going to be parallel to each other. Before I get too far, I want to just check my work. My cube is starting to look good, but I wonder, is this measurement correct? Is the measurement between the corner of the cube and the back of the cube correctly captured on my drawing? And to do that, I can take the height of the ball and I can compare it to the height of the cube and everything that I see in white, it's about half. So this is that measurement of 1 that I originally had, and I can think that that is about half. So I'm pretty happy with the fact that the cube, this and this and this is parallel, this and this is parallel, and that cube is starting to look correct. So now I have been using the ball this entire time, but I haven't even put it on my drawing. How silly is that? How crazy is that? But it's okay. We're about to do that now. So let me refocus on the objects, and let's start thinking. So I want to think about how far in does that ball start compared to the side of the cube. I want to also think about, if I'm comparing a vertical line to the side of the cube, how far does the ball stick out? And these measurements are a little bit small, so they're slightly harder to cite, but I can still think about them. So if I held my pencil vertically here, I think that the ball sticks out just a little bit further. I think that the ball starts just a little bit in from the corner. And I think that the bottom of this ball starts just a little bit in from this corner as well. And the middle of that ball, if I think about its height itself, is going to start at about the middle of this measurement. So if I think about this and I think about where the middle is, I think that the middle of the ball is going to be somewhere in here. So now that I have done that, have thought about that, let's refocus on the drawing. Again, this was my measurement of 1. And I can think, well, if the ball starts there, it's going to be about this high. And I'm going to take that measurement of 1 again, and it's going to be about this wide. And then I can check my work, make sure that the height and width of this object seem the same. They do. And again, sorry if the view of the paper is just a little bit distorted because of the tilt of the paper. But my ball is going to be somewhere in here, and it's going to be sitting on top of this cube. So then let's talk about the part, really the container we started with, but haven't quite finished yet. So there's a couple of things for us to notice about the container itself, the silver container. One, the bottom of this container is not flat. So currently I have it drawn as a horizontal line, but it itself is not a horizontal line. This line is curving, and it's because it's a cylinder. And so that cylinder has an ellipse at the top and an ellipse at the bottom, but we can only see half of that ellipse because the other part is being obscured by the silver container. But to understand this part of the bottom of the ellipse, it's easy to start to see the way that it's sloping away from a horizontal line. If I put my pencil right here on the bottom, and I start to think that, I'm going to grab another pencil to show you guys, and I start to think that here and here are basically two little triangles that are sloping away from my pencil. I'm going to focus on my paper again, and let's see if I can show you. So if I think about the bottom of my pencil being here horizontally, I don't know why, I'm just trying to get it to focus. There we go. Bottom of the pencil here horizontally. And if I hold my pencil, I start to see these two little triangles sloping away from my horizontal line. And if I think about what is the slope, and they're tiny, they're little triangles sloping away, it's easy for me to start to understand that shape. And once I have those, I can then curve that into the shape of the bottom of that container. When it comes to the opening, that top, what we're really looking at is an ellipse. And an ellipse has an apex, a height where it gets to be the highest, and a width where it gets to be the widest. And that is always going to happen in the middle of an ellipse. So if I put a cross in the area that is going to contain the opening of my little silver container, it makes it much easier for me to get that ellipse correct. So beginning students will make an ellipse. I'll just draw it down here, and it will look something like this. So the sides of that ellipse are not going to be symmetrical. This side is closer together, this side is wider, so that's not quite correct. Or they'll go like this, and they'll end up pinching the sides of the ellipse, doing something like this, where they come together, but there's no curve in here. So either the ellipse won't be symmetric, or the edge won't have a curve. But if you put a cross right in the middle of the rectangle that is going to contain your ellipse, it's much easier to know that the ellipse is going to start here at the edge, and it's going to slowly curve and touch that apex on top and bottom. And then it's going to curve again pretty, like slowly towards the other side, and then up. So now I have a much more true ellipse in here that is symmetric and doesn't pinch the sides of the container. So all of a sudden, I have used siding to describe these objects in their correct proportion. So really thinking about using the same measurement over and over again, extending your arm fully, using horizontal lines and vertical lines to make comparisons as to how objects are related to each other, how angles are sloping away from a vertical line or a horizontal line, how curved objects are actually sloping away from you, and thinking about ellipses and putting basically a cross in anything that is spherical or an ellipse. So that is the lesson in citing. I hope that it was useful. The only thing that I feel like I forgot to mention right away was that as we're citing, we're going to have one eye closed in order to be able to diminish our binocular vision and see in 2D. As I was using the camera to show you guys the sighting, of course the camera is doing that for you, but when you're doing that from a three-dimensional object, you need to close one eye so that you can see that measurement. All right, thank you.